In this video, we are going to create a blockchain using Python program. And before starting the program, I'd like to explain the web application framework. And here we are going to use a web application framework. The reason for using that framework for a blockchain is because we want to build a blockchain that can be used by anyone online using some servers. And the web application framework I'll be using is Flask, and there is also another client for testing web service, which is a Postman, which is a powerful HTTP client for testing web service, and it makes it easy to test, develop and document APIs by allowing users to quickly put together both simple and complex HTTP requests. So before getting started, you have to install Flask by using pip install Flask in your IDE, and we can start by importing libraries. So first I'm importing the libraries. So datetime and hashlib and JSON, and from Flask I'm importing Flask and JSON file. Yes, because each block will have its own timestamp, we are using importing the date time and to get the exact date and time, and hashlib is used for hashing the blocks, and JSON for converting Python object to JSON strings. And from Flask library we are importing the Flask class, because to create an object of Flask class, which will be the web application. And JSONify is a function used to return the messages to the postman when we'll interact with the blockchain. And the first part here, we are going to build a blockchain architecture. So I'm going to create a class blockchain. And I'm going to define function in it. So create block function contains a dictionary with the following keys of the block to be mined. And this function will also be used to verify the proof of work. Dictionaries associate values with keys, so you can look them up efficiently later on. So block is equal to index, which is the length of the self chain plus 1. And then next one is timestamp, which contain the string of date time. So index is the new block mined or added to the blockchain. Self chain is the blockchain itself, and plus 1 is the new block added now. And date timestamp is in string format, so that we don't encounter any format issues working with the JSON format. And next one is proof. And proof of work and previous hash argument will be defined later. And the next one is previous hash, which over the previous hash. And now self chain So we are appending or adding the new block to the blockchain and written the block. So returning the block to display the information, that is keys on the postman. So I'm defining another function, get previous block so that this get previous block function will return or get the last block of the blockchain at any time. So it will return the last block. So self chain of -1. And the next function is proof of work. So proof of work function having cryptographic SHA-256 puzzle problem where the miners need to solve it to get the block append to the blockchain successfully. So it will have two arguments. One is self, because we will apply the proof of work method from the instance object that will be created from the class, and the other is previous proof, is another element of the problem that the miners will encounter to find the new proof. So here first I'll assign new proof is equal to 1. So new proof is a variable that is initialized to 1 because to solve the problem we are going to increment this new proof variable by 1 at each iteration of a while loop until we get the right proof. Basically we are here trying to solve the problem by hidden trial method. So check proof is equal to false. So check proof is a variable that will check that new proof is a right proof or not. So it's a condition for the while loop. Check proof is equal to false means it is not the right proof. So while check proof is false, hash, I'm going to assign a value for the hash operation. So this hash operation is a variable of a string of 64 characters which uses SHA-256 function from the hashlib library for the cryptographic problem defined and is encoded in byte string format and converted into hexadecimal number. And then if hash operation of 4 is equal to 0, then so here we are doing slicing the hash operation to check first 4 numbers of 0. So more the leading zeros we put, more harder to find the golden ones. So check proof, I'm changing check proof value to true. So if the condition is true, then I'm changing the check proof value to true. Else new proof plus is equal to 1. So I'm incrementing. So condition to rerun the loop. So I'm return new proof. So next function is hash. So this encoded block is a variable which will convert the block dictionary having the 4 keys to JSON format. That is object to a string. We use JSON dumps instead of direct string method because in the next part we will put the block dictionary into a JSON file. Therefore the blocks originally will have a JSON format. So here I am returning. So returning the cryptographic hash of the encoded block. And the next one is define this chain valid. Chain valid function using the 2 parameters self and chain. So it's a function that will check each block has correct proof of work, that is proof of the problem that we defined is correct with the 4 leading zeros for each block, and the previous hash of the block is equal to hash of the previous block. One of the argument is chain because the checks will be performed on each blocks of the chain. So here previous block is equal to chain of 0. So here previous block is a variable that is initialized to a chain of 0, that is the first block of the blockchain. So we will start a while loop because we are going to iterate on all the blocks of the chain. At the end of the while loop, we will update the value of the previous block variable to the new block. So block index is equal to 1. So block index is a looping variable representing block number for each block. It has been initialized to the first block. So while block index is less than length of chain, so block index less than length of chain indicates the last block of the chain. This condition won't stop the loop until block index has reached the final index of the chain. At the end of the while loop, it will increment block index by 1 until it reaches the final index given by the length of the chain. So the first check is previous hash of the current block is the hash of the previous block. So this condition is for invalid blocks, which means the hash of the current created block is not equal to the hash of the previous block. So we need to take self because hash is a method of our blockchain class. So return false. So the second check is proof of each block is valid. So computing the hash operation of the previous block and proof of the current block and checking if the hash operation starts with 4 leading zeros, and this will indicate whether the proof of the current block is valid or not. So if hash operation of 4 is equal to 4 zeros, then return false. Now previous block is equal to block. So updating previous block, so it becomes current block because at the next iteration of loop, current block will become the next block of chain. So updating the loop variable, block index is equal to 1. And then return true. is returning true if everything goes right. And the second part is mining the blockchain. So we are going to mine the blockchain. We have created the blockchain as of now, and we are going to mine the blockchain. And for that I have to use the Flask of name. So to create web app, we have to include Flask. And then to create blockchain is equal to blockchain, which is a class name, blockchain of. So creating blockchain, an object for the blockchain class. And now we are going to mine a new block, that is first get request. So I'm going to type my first get request app.root of mine block methods is equal to get. So this is my first get request. So the root decorator to tell Flask what URL should trigger our function. So this is a root decorator to tell the Flask to what URL should trigger our function. And then for get method argument, you just check the arguments for get method in internet. And I'm going to define a mine block. So mine block function mines a block by solving proof of work problem but finding the proof based on the previous proof. That is the last proof given on the last block. So getting this proof means success in mining the block. So once the proof is achieved, we will get the other keys required to create a block. That is index, timestamp, proof, previous hash, like that. So in order to get the proof, we apply proof of work function, and in order to apply proof of work function, we need previous proof, and to get previous proof, we have get previous blockchain function, previous block function. So with applying the proof key of dictionary. So first we have to find the previous block. So previous block is equal to blockchain dot get previous block, and then previous proof is equal to previous proof is equal to previous block of proof. Previous block of proof, and proof is equal to blockchain dot proof of work of previous proof. This next one is previous hash, which is equal to blockchain dot hash of previous block. So to add a block to the blockchain, we have a function create block, which not only create but also append it to the blockchain. So to call create block function, we need previous hash argument. To get previous hash argument, we use this hash function to the previous hash of the blockchain. So block is equal to blockchain dot create create block of proof and previous hash. Since create block is a method, we need to call it from blockchain object. So it's a variable which will contain the information of the block and as well as a message. We are going to return the response in JSON format. So we are making the response a dictionary. So we will include the keys of the block we just mined and a new key as congratulations message. So I'm going to give a response which should include a message congrats, a block is mine. S is the message, and next one is index, which is the index in your block, and the next one is the timestamp, which is the timestamp in your block, and the next is proof, which is a proof in your block. And the next is the previous hash, which is your block's previous hash. Yes, this is your response message. So I'm returning the message, returning the response while calling the function the code. So we are also returning HTTP status code for success, meaning everything was fine. That is, the block was mined and successfully added to the chain and there was no error. So we are good to display. And the next one is getting the full blockchain. My second GET request, I'm going to get the full blockchain. So for this, app.root of get chain methods is equal to get. So here I'm defining get chain. So get chain is a function that will get the whole blockchain, so the below response can be performed achieved. So it will give you the responses. Response is equal to chain which is the chain of the blockchain, and then length of your blockchain. It will display the length of your blockchain. So this is your response message. So as new blocks will be mined and the chain will be populated with new blocks, so as to calculate the length of the chain, we will use the length to get the total number of blocks in the blockchain, that is the length of the blockchain. So I'm returning JSONify of response with a success code. So, and finally I'm going to run my application. So app.run of host is equal to 127.0.0.1, and I'm giving the port value as 5000. Yes, so I'm going to save this file as blockchain. So blockchain .python. So now we can run the file, and I'm going to check in the URL. So I'm going to check in this URL for mining the block. Yes, it is a block is mined. Now a block is mined here, and this is a previous hash, and this is a proof, and this is a timestamp used here. So I'm going to get chain. So it is showing the chain. So I have mined two blocks. The first one is here and the second one is here. So if I'm mining another block, so it will be the third block. Yes, its index is 3, and if I'm getting the chain, yes, it is showing you the blocks till have created till now. So this is how we have implemented, we have created the blockchain concept using Python and implemented in the web application framework using Flask. So thank you for watching.